Well, you're here. That's us. If you're looking for the bathroom, the men's is like behind the elevators, which is always confusing to me. Yeah, I'm Michael Proctor-Smith. I'm here. I'm really great at this, as everyone should know. Some Linux news. So they have a working model of that whole MIT laptop thing, which is kind of cool. You actually spend $100 on a laptop to the developing world with a screen that works in full sunlight and all kinds of fun stuff like that.
Did you hear the statement where I forget the guy's name, but the guy behind that project explained why you need volume to make the project work? Did you see that?
No.
Oh, he said he went to a laptop, or he went to an LCD screen maker, or he met with one of their executives, and he said, now he said, because of our price goals, we can live with a couple of dead pixels, we can live with this and that and the other thing. And the guy said, well, I'm sorry, but our strategic vision is we're going to be making everything with no dead pixels and this and that and the other thing. And the guy said, that's too bad because I need 100 million of them. And the guy said, we might be able to change our strategic That's why you need to build a lot of them. Yeah.
$100 million.
Yeah.
$1 billion.
That's too bad. I need 100 million of them. Wow.
$10 a piece?
I don't know what they're paying, but it's not. Yeah, but I mean that's not a small order.
Also, I can't pronounce their name. The guys that used to be IBM's desktop.
It's not Lenovo? What is
Lenovo, yeah, that's it. I wasn't going to massacre it on my own.
Just think, Jay Leno, vote.
They, just after our last meeting, they said, oh, well, we're not going to support Linux on anything that we build. And apparently, they, today or recently, went back on that and said, well, we were just kidding. If you pay for a license, we'll pre-install it for you, and we don't have a problem with that. Which apparently was, they don't want to deal with the licensing of Linux for some reason. Who knows why they would make that decision other than that whole Chinese decision that every piece of equipment that gets sold in China has to support Linux might have something to do with the Chinese company deciding that, well, maybe we're going to support Linux.
Yeah, I was wondering that. nobody drew that line, but I was thinking, theoretically, they can't sell in their own country.
Well, I mean, because yeah, well, it's pretty new in the last
apparently weeks. China has now said that you can't sell a computer in China that doesn't have Linux support for it. It's this whole, we don't want to be dependent on a large American company.
How would I have not heard that? I'm a Linux professional.
Because you spend too much time doing real work and not enough time trolling websites.
You don't read Slashdot like incessantly. You don't have an addiction.
You don't spend enough hours a day reading Slashdot.
Or just reloading the page, going, "Come on, there's got to be a new story. New story."
Remember, I think I sent you an email that said you need to get somebody who has the ear of the top brass, whose job is to spend 2 hours a day reading the movers and shakers.
Trolltech, all the UKE fans, they're guys behind QT. It's apparently going public. Good for them, I guess. One of those Scandinavian countries, I think, is where they're located. So it's not exactly probably the same as going public here. Who knows? They're allowed to say stuff. So because it was short term before they were going to be going public too, compared to what it is here. And Andy Tannenbaum and Linux Torvalds had a nice little back and forth discussion over the whole macro monolithic versus microkernel. And I always love the engineering argument, which is, no one's really gotten those microkernels to work very well, have they? Somebody let them in again would be great. Making you do that.
Remember that, because I'm going to refer back to that in my talk.
I knew what the main presentation said. I didn't actually call with you for the short presentation, and no one volunteered, but I think.
I did.
I think
Tom did. Yeah, Tom did. He was gonna boast about SUSE 10.1, I think.
Yeah, it was
pretty much what I was talking.
You can give him one set of discs.
Does that mean it took you all the time since the release to get it installed, or?
Well, part of that time was waiting for it to download through BitTorrent, and then re-upload, and then finally burn the discs, and then finally deciding to actually take the plunge and wipe out the hard drive and start over and all that, which meant I had to back this up and all those fun things.
Which of course you do religiously daily anyway.
Yeah, right, that was the Windows partition. Actually, the other part of it was that Windows itself had finally completely died on the system. I was getting the green screen of death where it comes up to just the first background and no icons ever show up. Anyways, other brief item, I had this one that I got from the Pomona Computer Show. They were giving away iPods as a come on to at least sign up with them. Linux workshop. The only thing I realized after I got this home was that they have the wrong name for teaching Linux, and that is Gates College. I don't know. Maybe that's why they reduced the price. I don't know. But they're currently local here in Pomona. They stress that they will not be learning how to use a GUI. You'll be learning how to use the command line. But I have this in case anyone wants it. They're in the Computer Shopper magazine. They're fairly local. Anyway, so as I was installing SUSE, I took a moment to actually write down some of the neat things I saw on the installation list of things that weren't defaults. And I came up with this one called ImageSeek. And something about the description of it caught my attention. It said, you know, how do you search for images? Like, say you wanted to find a spoon, a picture of a spoon. How do you tell a computer to search for a picture of a spoon? Well, it turns out they have a very simple way. Spoons are kind of gray, they're kind of round, they have a handle, and you say, search for spoons. And there you got spoons!
Plus, how do you get trouble? Being choked?
Okay, well, I happen to have a whole lot of other pictures on there, but it was kind of amazing that, yes, indeed, it would actually find things sort of close to what you drew.
Wow.
That was like,
That's pretty impressive.
If you drew it like sideways.
you do it vertically? Yeah, erase that. Well, let's see. We have around, sort of thing like that. You find the vertical spoons they have pictures of.
So that's the limitations. You have to know the orientation of the object you're searching for.
Yeah. Then you can click on it and we'll find more instances of similar objects.
Are those other objects similar to a spoon? And
You use a spoon to eat cheesecake?
My sister collects spoons and such. Well, the other semi-nice things.
You drew a picture of a fashion model.
Huh?
You drew a picture of a fashion model.
Yeah. Unfortunately, that's a really tiny window and a really big pen. But they also let you do things like import other media. Now, it turns out that one of the other things, I guess, this is mostly probably KDE. They have their My Computer folder, which looks like somebody else's My Computer folder nowadays, which automatically pops up the fact that, hey, there's this new volume out there. And it's got pictures in it. And let's see if I have a good picture of this profile. That one? No, not that one. That one's just a little blurry. He moved.
Sure. It's the dog's fault, not the operator.
Okay, there's my dog.
At that size, it's almost scary. That changes everything.
So if I come down here and I say, import, and that happens to be on media, domain, DSIM, 100 Yep.
Oh, I see, search for other.
You keep
There's
somebody
another
else's names.
Now-
Alternate spoons really kind of mess up your system.
No, this is cache from what it had
It's
before.
pre-programmed for computer users, no matter what you type in, it always hits the cheesecake.
You know, I think you're letting me remember what the picture, what most of his pictures are of.
Yes, yes.
Okay, I happened to find a really nice site. I use that for my wallpapers. Okay? Well, it's got this one that says, find a random selection. That works pretty good.
Spoons.
I'll never look at silverware the same way.
Okay. Let's see.
Do you happen to know if this is a mono application?
Since it's part of KDE, it's probably a QT.
I knew there was a lot of new mono things.
Yeah. It turns out that I think it does mostly the average color and probably some primary shapes, or I would say maybe a Fourier transform on the image to see where the boundaries are, to look for a similar image. I don't know, the guy had, it turns out,
You'd want to do a wavelet transform.
yeah, it turns out that one of the other things it will do, actually, it lets you group things. So I can't have these things. So I want to do Renaissance there. Is this the one? Yeah. While I was there, I saw this guy. I don't know if you can see him all that well. Oh. That's Ted Arden, happened to meet him down at the Renaissance Fair. Guy from our Linux group. Works with VA Linux, you know, that little tiny startup.
Used to work on UVLS.
He was selling, you know, hardware at kind of a fire sale. That's where I got my dual CPU system for.
What company is this you speak of called VA Linux? There is no such thing.
I still got some of their stock.
Well, they're not called VA Linux.
Anyway, so then some of the other things it does, I think it says, yeah, create HTML.
Does it do a slideshow?
Yeah, slideshow of the entire collection, which is going to be kind of random because I've got all sorts of things.
More smooth.
As you quickly edit and stuff.
And spoons, yes.
Sorry, the last picture. Go back to it.
I wonder what
Okay.
the transfer.
Is that a fast way to transform?
So I just figured out how to do it the other day. You add things to the batch and you say, yeah, we want the dimensions of the thing, and the file size, because I haven't actually done anything else. And it looks like it'll pick up all sorts of EXIF tags from the image itself if they happen to be in there. And quite a bit of them. And I guess
Can I make
that.
that an album?
We're gonna do that and say finish. And hey, it said it did something. Yeah, generate an album. I say home directory. I should have something called new album. Oh, which actually had another on it.
Is this your old slow computer?
This is my old slow 1 gigahertz computer, yeah. So it generates a web page, and when you click on
Whoa.
things, it shows the whole thing.
Whoa, you mean it makes a thumbnail and the link?
Yeah.
Oh,
And it'll make it so you can export it out to your web provider and all that. Lady played and clean. So that was some of the neat stuff that I happened to pick up in this last batch. Any thoughts, comments, or questions? You want to see some more of the cheesecake?
Spoons.
Just a nice pair of spoons.
Is there anything in this that Novell would have put in? That Seuss was,
Well,
had
that's,
some connectors?
yeah, Novell basically bought Seuss and is now running the show behind our funding, I guess, behind
Right,
it.
so you'd assume that maybe they were slipping something in,
Well, there's Zen
yeah.
and all that, which I haven't checked into yet. But apparently it's a lot
The
easier to
answer is
install it.
if Novell wrote it, then it probably came from the guys that used to be with, I forget the name of that company that Novell also bought.
Simeon?
Simeon, yeah. And that's why he asked about mono, because they're the mono guys too. So,
Well, I know that there were a couple of things now in 10.1 that pretty much if you use a desktop their way, you're actually depending on mono, which doesn't happen. I mean, no one's needed mono for anything before. I think their desktops, I think Beagle's in mono. So, you know, since everybody but me seems to have trouble finding their files, apparently. That's what really deep directory trees
Yeah,
are
that'll be the
for.
one. Oh, no, see if there's an XSI one there. Yeah, that's newer.
Okay.
But it's with the info folder and I'll in there. To wait for that one to.
This will probably be the first time I fired up Open Office on the system, so we'll probably do fun things too. The thing about this is it's now being done by a group calling themselves OpenSUSE. So at the last release, it was available for download the day it was actually released in the stores. This time it was actually available for download before it appeared on store shelves. But and then I think after it was available for download about 5 days later, it was available from Novell online.
well, OpenSUSE is Novell's attempt at,
Right.
Fedora.
It's like it's another group that's actually providing it or doing
No,
it.
if you understand the Fedora Red Hat relationship,
Okay.
OpenSUSE is the exact same relationship.
Okay. So this is
Tom,
still,
we should move to that, please.
Yes, it's Amazon Fire and Freestyle. Yeah.
actually, let's do this.
Oh, and by the way, if anyone that got here after I said it, there's no access point here, so that's open. It's not Caltex, so if you're trying to get your network to work and well, it's my fault. You can stop.
You know, Mike, we'd fire you, but then we'd have to find a replacement. So you're totally safe.
Congratulations, Dustin, you've been elected. Oh, what's up?
See what
It never works. I keep trying to do that, and people are like, "We should do this," and I say, "You should do that. You're now in charge of that."
If nominated, I shall not run. If elected, I shall not serve.
Have who? Have Paulson.
Have a better
It's a little oversized.
Right. Oh, that's what it is. Slideshow. Custom.
Just hit F9.
Things have changed slightly since last time.
Or F5.
Slideshow
They changed it.
Run in a window.
Trying to run it in the window to resize it.
Hit F5 now. Hit F5.
Where's the full screen? I know that, but there was a way of.
You told it to run in a window now. Tell it to.
Huh?
You told it to run in a window now. Tell the slideshow to run.
Right.
Just
Okay, well. So these windows drags faster for you? There's a way of getting rid of most of the other decoration around it, in at least the older version of it. So I think we're moving on to our main presentation.
Hi. Thanks for inviting me. Us, David Fox, sitting down here. David and I have been colleagues for a long time. And we were sort of the first two engineers at Linspire, and we remain sort of the lead engineers of the OS group there. And we've been using functional programming for a very long time. We started with Scheme in 1990 or something like that. Well, Lisp before that, and E-Lisp before that. So we've been using functional programming for a very long time. Yeah, 20 years or so. So recently we announced that we were standardizing the OS group on Haskell, which means that we're continuing to do what we normally do. There are just a few more people who've been converted to using functional programming. We've all decided to use Haskell together. We've announced it to the world, which made some of our colleagues a little uneasy that we were standardizing on such an odd language. But really, life is better given what we're doing. So I'm going to explain why we've made these choices, why we think it's the time to do it, and give you a little introduction to Haskell, because most people haven't seen it at all. Am I right? How many people feel they know Haskell? I had the sensation that you did, so you can correct me as I go along. I'm going to give you an overview of what we do at Linspire, what our goals are, and then give you a sort of whirlwind tour of Haskell to try and excite you. Then I'm going to show you what we're building with it. All right, so we're not focused on anybody in here, at least we haven't been till date at Linspire. We're focused on the consumer market and OEM installations, and Michael Robertson's original goal was to sort of pick up the whole Windows 98 market that was not willing to buy for XP. So there was always this goal that we never had in the clickety-clack. So it's not a typical Linux distribution. We try and make everything come up and work and just automatically go there. We don't focus on making, putting up, oh, you just do run and patch things. We do everything all together. Our big product is Click and Run, which is a one-click thing. I would show you a little more of it, but I'm not on my machine here. Basically, it's a web application. We distribute we take all of the Debian repository of software, plus ones we've contracted for. We make nice web pages for them and put them up. Linspire users can go open up the click and run client. They see an application they like. They click on the green running man. It installs it on their system. So it's a wraparound app, but that's a very small way of saying there's a big delivery system there, which makes it very easy. When we first got it going, David's kids, Michael Robertson's kids, they were all playing games on Linux because they could browse web pages and go and play. 5 years old, 6 years old, they can go and do this. So it's pretty cool. So the question is, how do you go about making something like that happen? This is the original goal here. Really is to try and focused on click and run, to try and make a software marketplace where many producers of software can communicate with many users of software, much the way that MP3.com worked for music, where independent artists could communicate with people who liked independent art, which there are not all that many, as it turns out. We have a community translation and Irma tool, which is we put the packages up on the website and people can go and translate them, and then we turn out OSs with them. David is in charge of the hardware detection, and if you haven't tried Linspire, you may want to try FreeSpire when it comes out and try our hardware detection, because I think it's second to none, really. So FreeSpire is going back to, as we were talking about with the OpenSUSE thing, it's to go back to sort of a more traditional Linux model to get, the CNR thing works. We know that, it's pretty well developed. FreeSpire is to sort of try and tackle a medium level distribution where developers can use it. All the man pages are installed, man pages and compilers are not installed by default on Linspire because our assumption is that people don't even know what they are, just the way they do on a Windows machine. So this is more like a traditional thing. However, we maintain what is our strength, which is a simple desktop, and one of the things we focus on tremendously is file type supports. We make sure there are MIME types for every kind of document out on the web. If you go to linspire.com/file types, you'll see a huge list of document types, media formats, all that kind of stuff. Windows codecs, Flash media players, all those, before we ship an OS, all those work out of the box on the little click out of your browser. Two, if you play Flash media things, they will stay in sync, the audio and the video, which you'll probably not find on any other Linux distribution. We work very hard at that. I haven't tried them recently, but that's something where things fall down. And that's something you really need if you're going to the supermarket, is that if you play the llama song and the llamas are over here and you're getting the lines, if you don't know the llama song, go look at it. It's a great way to tell if your video is staying in sync or not. So FreeSpire, we're tackling the more difficult crowd, really, which is developers, because they want everything and they know everything, right? So they want things to be the way they have experienced it in Linux for a very long time. We take a few liberties and tighten a few things up in Linspire. FreeSpire is supposed to do that. And we're going to make CNR more developer friendly so that you can get source code directly using CNR. You can make some patches. Oh, I didn't like the way they do this. Just ship it back to us and hopefully we'll grab it and toss it in and make it available. So we're trying to harness the developer community more. And we've always kept our app pools closed because management thought that was a good idea. And they've finally seen the light on that one. Okay, so the process of building a Linux distribution is like laws and sausages. You really don't want to see how it's done, how they're made. And if you think about it, we're derivative work, right? So we start with a huge database of code, we tweak it, we distribute it for lots of people to use for many different reasons on lots of hardware, and then we go around again, except you got to do it all again. And that's not your typical set of programming skills, right? Most people, they work with a code base, they create a program, and they maintain that one program. We problem hop like mad, because what you got to do is go in and fix OpenOffice because it doesn't do this one thing. So you got to pull in the million lines of code of OpenOffice, fix 5 things in it, and try and send it back to these guys, and send it off to these guys. So we find that we have pretty high-level people working on things on problems that require a great deal of flexibility. So example, David is always debugging machines that he doesn't actually have. So it's a question of gathering information from our remote machines, diagnosing what's wrong with their X server or something like that, and modifying the detector so that when it goes back out, it will actually work correctly on their machines. That's a non-trivial thing to do. So, packaging, even just the simple act of putting software into Debian packaging is a non-trivial thing. Anybody who's read the Debian policy manual will understand that. Release management is not a solved problem in any distribution, and there are certainly the tools for it are kind of flaky. Hardware detection is getting a lot better, but it's still kind of weak. We have a small team, so in order to tackle these big problems with a small team, where the community is not tending to solve these problems, we feel we need to use the best single tool possible, and that's functional programming for us. So the biggest reason is static type checking, okay? When you compile a program in, say, Python, it's possible that you're left with a situation where one object will send a message to another object, and that other object won't be ready to receive that message. It won't have that method defined in it. Static type checking leverages the mind share of the theory community to help you as much as possible before you send the thing out in the field. So the goal is to reduce runtime errors. That's one of the biggest reasons we do. I mean, and leveraging the theoreticians is the best thing. There's a term that they use all the time called referential transparency. Roughly speaking, that means you're not allowed to have side effects in your code. Okay, you're not allowed to write a function that does some I/O on the side unless you say that function is going to do some I/O on the side and you construct it in there properly. Okay, so it's a little bit sort of, you know, it's like putting on a spacesuit. You're a little constricted, and if you got to go to the bathroom, you gotta be prepared for that, right? So it takes a little work, but the big goal here is that getting rid of side effects lets the theoreticians run optimizations that they couldn't otherwise do. So for you in the compiler, and you have the potential for parallelism out the backside. And as we've all seen with dual core processors coming around, it looks like quad core processors are right around the corner. Exploiting parallelism is going to become more and more important. We deal with a myriad of little languages and two-level languages. Python is a two-level language. You have a nice interpreted environment, but as soon as you need to do something serious, you drop down into C++ and write some stuff there, and then you go back. And so you have this sort of dual layer kind of thing that you talk between there. Tickle-TK did the same thing with C. There are lots of examples of that. You have little languages, awk, sed, these things which lop off a particular problem like text processing, and they try and optimize for that. Then you got to learn the the regular expressions for awk, the regular expressions for sed, and the regular expressions for Perl, which are all different. And Perl is actually really does the best, but then it's kind of got its own crazy little space going on. And it's just, in terms of data structures, hash tables are fabulous, but going beyond that takes quite a bit of work in Perl. So anybody who's really interested in this, John Hughes wrote an excellent paper, which is easily findable on the web, called Why Functional Programming Matters. So Haskell in particular, David has been programming in Camel, Objective Camel, for quite a few years. It's got a very fast compiler. We just forced him to switch to Haskell within the last few months, and it was, nobody likes being knocked off of their favorite tool, right? But on the way up today, he's like, well, there's just something about Haskell that's just a little bit better, the libraries are better, the language features are better, and it makes things much more, just that much tighter and that much more efficient. It's got a long history. The most interesting thing to me is the Glasgow Haskell compiler was originally started at Glasgow University. The researchers who now maintain it are paid by Microsoft and work for Microsoft Research. There were a total of 80 proposals from students for Haskell Summer of Code projects this year. 9 were accepted, and they're all on sort of core interest in Haskell projects. So you can go to the IRC channel for Haskell, and there's over 100 people on there almost constantly. So the community's growing, it's looking more interesting. Okay, this slide doesn't have, I saved it in a format which I was sure that this open office would understand. I started with top 10, and I did a strikeout on it, and I went to 15, and I went to 20, and I stopped counting. So there are a lot of wonderful features in Haskell, so here's the whirlwind tour, okay? First of all, it's beautiful. It has this look and feel of being typeset. And this comes from, in part, well, it was a very conscious design on the, conscious effort on the part of the designers to make it look like mathematics. It stems from mathematics. They wanted to do as much as mathematical as possible. So it looks like mathematically, like a good mathematics textbook. And part of this was they left out all of the curly braces and semicolons that you find in C. And so if you indent a little bit, I think I have an example. Nope, I do someplace else. If you indent, oh boy. I know what's going to happen. That next slide didn't say, well, we're going to have to redo the thingy. But if you indent your code, that's fine. The code is not here.
It's on there.
Yeah, no, there's a figure there that's missing because I didn't do the right one. Is this on mounted?
Should be everything up now.
Window, I think.
Well, your key, that is. Your key is not. We're not running off of your key, right?
Right. I moved it to our.
Right. So presumably I can pull that key and
Around this one.
sorry, folks.
See what happened with the sun.
Yes, that's exactly right. That the open office format does not understand
Everything goes in one file.
well, it just doesn't understand certain things. So it says it just goes ahead and tosses them away. So let's switch to this one. Normally I would just fake it, but all of the figures for the next 15 slides are in there. Okay, so let me try and explain the point about the indentation while Tom's helping me out here. That white space matters, so if you indent, that's like creating a block structure. So it's like introducing a curly brace in C. So you can get rid of all of the curly braces, you just indent your code correctly, and that creates the block structure for you. So it reduces the noise a whole lot.
You want this one?
Yeah. Yeah, there you go. Now we're in full screen mode, just cut off here. So,
Trying to get
oh,
roughly
get to
to that
right.
page.
Yeah, that's. You just say okay, and you know it's fine too, right? Okay, great. Thank you. There we go. There's an example of white space, and here's an example of. So on the example, this is straight out of the prelude for Haskell. This has been locked here, but so this is actually supposed to be at the end of the line. But you see this code, there's no curly braces, everything's just indented, and that gives it this sort of nice typeset feel. You can use the curly braces and the semicolons if you want, if you're generating code or something like that, you can put them in there. But as a result, the code gets a nice look to it. Yes?
Yeah, that's essentially,
Yeah.
it's essentially the same as Python, except in Python, you don't get a choice.
Right. So lists are a big part of functional programming. The lists are built in, although they are not really, I mean, they're defined using the mechanisms of the language, so you could get rid of them if you wanted to. So they're very carefully constructed. You can take an element and compose it onto the front of a list, which is represented by square brackets and that, and you get back 1, 2, 3. Strings are lists, so if you take a list of characters and give it to the interpreter, it'll say, oh, look, this is a string, and give it back to you. So there's this nice, it shows strings as strings all the time, but in fact it treats them as lists of characters, which means that all the tools you work on lists, there's this nice big library for working with lists, it's sort of the default data structure, you can use all those to do all your work on strings if you like. So, so I talked a little bit about the static typing before. The goal is to reduce the runtime errors. The other nice thing though is that the types are inferred. The type system is carefully chosen so that there's always sort of a minimal answer to when the compiler can look at an expression and it can figure out whether it's a valid expression or not, and if it is valid, it can figure out what the types are. So you can put signatures on your functions. That is, you can say this function has a particular type, but you don't need to. People do it as a way to document their functions and make sure that they're getting what they expect. So here's the interpreter again. I'm asking it what the type of this function is, hello, which takes a single object and says, is it in this list of objects? And returns you a Boolean value. And we'll just ignore this part right here for now. And it says, well, it's got this funny type out here, okay? It says A, and a list of A, and a Boolean, with the arrows in between them. But when I ask it to, what's the type of ln applied to the number 2, it says, oh, well, your type has changed now. This thing is, you notice that this part here has changed. It's going from something that's called EQ of A to something that's called num of A. And this first A has disappeared because I've provided it already. Okay, so I'm going to explain a little bit of the magic of what's going on there, but the important thing to notice is that it figured out that something went from type being EQ to this num going on, and it got rid of one of these parameters on this type function here. This is a very nice feature. It lets you sort of write code in a big hurry, and you come along and put type back on it later. So what are those type variables, those A's in there? Those are type variables. And here's a definition of a tree, and this is a type variable. So I'm defining a new type called tree, and it can be a tree of anything, a tree of A's, right? So a binary tree consists of a node with 2 trees of the same type in it, or it can be a leaf with something of that type in it. So that's, I mean, what you would get from, you could easily define this in C as well, but the abstract, the algebraic data type description is quite nice and quite pleasant to work with. I'm not going to go over pattern matching in this talk, but walking over a tree like this is very easy with pattern matching and with the polymorphic types that are there. Lists are a parametric type, and they've got a special notation for them, but they can be lists of anything. So here's an example of where you get wonderful benefit from functional programming. Here's a function called map. And if you take a list of anything, and in this case A's, well, let's call them integers for now. I've got a function, say, that takes integers and it converts them into their corresponding string to print them out. Map will take that function, the print function, or in this case the show function. I've got a list of integers, and it'll give me back a list of strings. So let's see some examples of that. In this case, reverse is a function that takes a list and reverses it back to front. So I now have a list of, lists, because strings are lists. So I'm going to take reverse and apply it to each of these strings in here and get back a new list. Okay, so I'm going to take reverse, and I'm going to say reverse of hello, reverse of there, reverse of world. Get back a new list.
But it doesn't reverse the whole list?
Nope.
Because he mapped it over the list.
Right, so I picked a little tricky example there, this is sort of subconscious. Well, let's look at the next example.
If you took the map away, then it would just reverse the list.
It is, don't go there. Successor is a function that, given an integer, returns its successor, so it adds 1. So, in this instance, I think what's going on is marked there. I have a list that's 1, 2, 3. I'm going to add 1 to each element of the list. I'm going to apply the function to each element of the list. Okay, so I get back a list that's really successor of 2, successor of 3, successor of 1, which is 2, successor of 3, etc. Learning Haskell in this format is really not possible. So, this is one of the things that's a little, the downside of functional programming is the learning curve is a little big. It helps to have somebody sitting there working with you for quite some time. As a colleague of mine at work said, it doesn't really leverage the mind share that I've been building up for quite a few years. The C++ and all this other stuff he's been working on, things are very different here. And that's true. But it's worth it if you take the time. So here's another function, fold. Okay, a fold is, you've got a list of things and you've got an operator. Let's take the operator times. I'm going to stick, every place I've got a comma, I'm going to put the operator times. And I get an expression, 1 times 2 times 3 in this instance. I take that expression, I evaluate it, and I get back 6. And in fact, this 1 right here is, it'll take 1 times 2 times 3 times 1. So you can give it sort of what's the 0 of your, algebraically speaking, the 0 of your monoid or your group, and put it in there. Now, but you can think of that basically as just, you've got a big long list of things, you want to smush them down into one value by putting an operator in between each of them. That's what a fold does. And notice,
so the reason for that first argument is essentially to make it behave reasonably on lists with 0 or 1 items or something.
Yes.
Because otherwise it doesn't actually mean anything.
That's right. There are also trickier uses of fold that are way more advanced that you can start doing stuff with that value with. But that is sufficient for now. Notice in all of this, the definition of fold doesn't know anything about integers. It simply is given a function, the operator times, and a number, and these guys, and it just goes off and applies that function. So you can write things that operate on structures that don't know very much about the types inside of them by using functions to sort of separate you from the data, handle the data. And that, in practice, means you get to reuse your code. And you get to reuse a whole lot of functions that these guys have written for you. And the list operations in the default library are very, very complete. And every time I start writing something custom program to look at the list, I look, oh, well, it's really if I just take it like this and I do it like this, and I fold it and I zip it together and I'm all done. So here's another couple of examples. I told the interpreter to bring in, here's the module system at work. I told it to go out and get me the data.character module. So these are the functions which are used for handling characters. And I said, let's map the to upper, which takes a lowercase of any string and puts it into uppercase, across the list of characters represented by the string below. Of course, it returns you this, okay? So we're seeing that this is a little tricky getting used to the fact that strings are lists, but this is exactly equivalent to seeing things in square brackets. So here is zip, which takes 2 lists, and I went ahead and did the tricky thing of using a list which has got the square brackets and the commas, and a list which is just looks like a string, and it sticks them together into these little pairs. So it goes down each list one by one, it takes the first element, and sticks from each and sticks them in a pair, and the second and the third together.
Question.
Yeah.
If those lists did not have the same number of elements,
It would just drop off. It would just drop off the stuff from the longer one.
Really?
Yeah.
But that's not, so in Haskell.
That's a feature of zip that it goes down and it says, well, if I've got an empty list, then I stop. It could be written to throw an error at that point. You can do whatever you like.
But that would be a runtime error because it looks like the length of the list is not a part of its type. Yes.
That's correct. Not completely true, but the default list, yes. And I'll get back to, ask me that question at the end of the talk about the lengths of the lists, okay? Zip width, in the zip width case, my second argument got down here. So that's the arguments to the function. I say zip width, here's the function plus, and I have two lists, one of which is 10 times the other. And zip does the same, zip width does the same thing as zip. It takes element piece by piece, but it applies a function to unify them into one value, and you end up with a list of things, okay? So my goal here again is not to do a tutorial on Haskell, it's to give you a sense of, if I can use these functions in here, and the types all just magically get sorted out, but it doesn't let me do anything bad. It won't let me add an integer in a string. It'll never let me do that. As long as my types are correct, then I can start doing all this powerful magic with these guys, and it doesn't take a whole lot of space. I don't have to write big for loops with curly braces and things. I can start putting these things in nice tiny little spaces. And you start learning these things, and you're like, oh, well, yeah, just zip and map these things together. It's like Legos. You start putting stuff together, and off you go. Did I go back one? Oh, no. Here's another example of fold. Okay, so again, here, a fold. We take an operator, and we put it where the commas are. In this case, I use plus where the 0 is 0, and I get back the answer 6. I can do the same thing on strings. In this case, I chose as my 0 the empty string. I have 3 strings here in a list, and it sticks them all together. Oh, I'm sorry, this is the string this is the list concatenation operator. Take 2 lists and concatenates them together. Strings are lists, so it concatenates them together. So you start developing techniques, and you learn these techniques, and this language has sort of, it's almost annealed to the point where these things are just so convenient. And some of this stuff is made possible by type classes. Here's one of the cool things about Haskell. Haskell was started in 1987 by a group of researchers. Is it running out of battery?
It shouldn't be on battery, but I think it's just on.
I see it on my screen. It's not a screen light, it's a video problem.
Oh, you know what, maybe the projectors has been running long enough, it doesn't want to run anymore.
Overheating.
Also check the simple things, like make sure the plug is still.
Is the light on, Tom?
No.
There's just one red light on.
Then I went to sleep.
I didn't disturb the cord, did I?
No. Okay. Next worst thing. Everybody move it close.
Hey Tom, I think we should blame it all on Susan.
All right, and here's what I'll do. I'll try and do this without.
Green light. Green light.
Green light, there you go.
Yeah, it overheated.
Have we had it do that before?
Yeah, I think it did once.
When did we move to this room? Was it after the summer?
No, because I recall that we figured out that during the summer, the buildings are actually locked and the doors in the classrooms are locked.
Right, so we
have figured that out.
Okay, so a type class. Classes in C++ have methods, functions, which are defined to operate upon the data that you define in the class. Right? Java has signatures, which it uses to do multiple inheritance off on the side, right? And a signature doesn't let you do anything with data. It doesn't let you do inheritance. It just lets you define kind of a function. That's the closest thing I know to type classes. They were introduced halfway through the history of Haskell, and they really, really improved it. Unfortunately, they're a tough subject, but I'm going to try and get it. For every object in the language, the show class is defined. So you can take anything in the language except a function. Well, you can even do it for a function, but for all data, the show operation will convert that data to be a readable string. So if you just say show on the number 1, it'll give you back a string that's the number 1 in the string. Okay? So the class show says anybody who's an instance of the class show needs to provide this operation show, where I take any, whatever you guys are. If you're an integer, then we need a function that's an integer to a string. Okay, so in the case of integers, the thing that it's like printf, or sprintf more technically, right? So that it takes an integer and gives you back a string. So you can create an instance of show, so for my type, and you can put in strings of my type that indicate that, and then you can append, whatever the language wants to do for the show of the data you've got inside there. So you can recursively do that. So in other words, every time if I created my type or an instance of my type or do a show on it, I'm going to get something that says my type and then say the number 1. If I had an
interesting instance you've got there.
Yeah. It's actually hard to write an instance of show, as he's pointing out that it's sort of a recursive definition. But this is actually the definition that the language will derive for you. You can actually create a class, a data type, and say, just derive me show, and it'll make one up that's more or less like this. And so the busy work of I've got to make a printout of this out of this data structure. I've got to write some code to print some stuff out. You can just say derive me show, and it'll give you a reasonable representation of that.
That almost looks, that recursive definition almost looks like a call to super.
Yeah, more or less. You want to get out of your mind the C++ took the data.
Well, the C++ doesn't have call to super. I'm thinking about more like Objective-C or something.
Well, all right,
have access to the previous method that I'm about to override.
Right. Well, I don't like that.
Okay.
I don't like that representation. It's more of a recursive thing. I want to show a tree of integers. Here's how I show a tree. Integers know how to be shown. I will recursively call the show for integers. Okay. And that representation is much nicer. C++ is left me rather scarred, I think. But and one of the reasons the type classes are so lovely is they separate the data from the methods. You don't have to define your block of data and then the methods on it at the same time. You just define what the methods you want to be, and later on you say, well, hey, this thing should be an instance of that class, and I'll show you some examples here in a minute. And then you can define what that glue should be that puts the two together. Okay. Now, how do you use type classes? You saw earlier that I changed the type on something with the enumerators. This funny syntax right here takes a while to learn how to read. But what this says is, if I'm given an A and it's an instance of the type class ordinal, then I can make this function list of A, give me a list of A, and I'll return you a list of A. But if you give me something that's not a member of the ordinal class, this thing is not going to work on it. Okay? So, what does that do for you? Well, this hierarchy is probably a little tough to see, but the big letters are all that's really important here, right? So this is EQ. If something, almost all things are members of the EQ class. That is, you can do equality testing on them. Things that are not members of the EQ class are functions. You cannot take two functions and compare them to see if they're the same function. Yeah, you might want to think you could, but theoretically you cannot, right? Okay, so...
Yes. So you can't in a nicely implementable way on a computer.
No, you cannot guarantee that the answer will be correct.
But that's what I'm saying. This is a computer limitation. The notion makes sense.
It's a computational notation.
Yeah, the
It's a
notion,
serial, it's a
the
computational.
mathematical notation makes sense, but it's not something you can actually provide in the
It
computer.
doesn't make sense in a computational sense. You can't compute it.
I think we're saying the same thing.
Yeah, I think so, but your language is making me a little unhappy, so.
I'm a physicist, I don't write that.
Yeah, it's, you know, I saw, never mind, I'll tell you that joke later. All right, where are we? I'm approaching an hour and I've got a ways to go yet, so. I said this was a whirlwind tour, but this is the most important part. So I'm going to get to a little bit cool stuff, but I want to spend a little bit of time on here. So, almost all things say, all data types basically support EQ, and EQ is another one that you can derive. You don't have to define EQ. There's a natural definition for it that you recursively work through your data structure and things are there. You can change the definition if you like, but the compiler assumes that EQ is really equality, not like C++ where you're overriding assignment and doing something tricky behind the scenes. This is things. Ordinal means I can compare these two things. I can tell whether A is, item 1 is greater than item 2, okay? And that's why the sort operation says, hey, if I can compare these two items, then I know how to sort a list, right? That's all I need to do is compare them. So if you make two matrices, and you define them as an instance of the class ord, God help you if you do, right? Because they're not. But if you do, then the compiler would try and faithfully do that. I mean, if you said, I'm going to sort my matrices based on the first element only, or something like that. But all of the data types implemented in the language, you can go and read the headers, and integers, there are a few things that are done at a sort of low level, but strings and lists and trees and all these things, they just derive EQ from them. So if you look around here, you'll see numbers. I have real numbers, I have fractional numbers, I have integral numbers, I have real fractions, floatings, real floats. So the typical, the hierarchy of numbers, things you can do with each of these things are defined. You can't do multiplication on things with ORD only. But you can do multiplication on anything with none. So if you go and look at the type signature for these things, it'll say what class you're in. So you can define these methods, you can define your functions, and you can basically go in to a lot of these things and say, well, yeah, I don't really need to be a complex. Oh, complex is down here someplace too. If you really need complex numbers, then you'd say I need complex at A, and none of those operations up there are working and have to redo them all. So, but this is, the point is, mathematics, this hierarchy has been around for a long time. It's actually significantly larger than this. This was shrunk down to be practical. But it's an implementation of abstract mathematics, or abstract algebra. So, lambda functions, anonymous functions. This is again about keeping things small and powerful. The lambda character is represented by the backslash with the leg dropped off. So this is I have a function with an argument x, and it returns x times x. And the compiler will infer there that that needs to be, if you ask it the type of that, it'll say, well, you're using times, and the times is, the times operator requires a number, so it'll give a type in there that is restricted to being numeric types of this thing. We'll figure that out. Here are some other tricky things. It's important to note that you can create expressions where you have values outside. I'm going to define x to be 17, and I'm going to use it in this expression. Okay? So I'm going to say lambda y, a function with an argument y, which is x times y. Well, x is 17, so I'm substituting the value of 17 right there, and it'll return me a function that is y times 17 for whatever value you give it. So things outside the scope of the function are used, and then they're bound inside the function when you return them. Okay? So that value gets caught in there, and the result of this expression is a function that has no name, right? I just built it in place. How do I use that? Well, here's the function up here, the square function. I just wrote it right in place. So I can map the square function over this list, 1, 2, 3, and I get back a list of squares. Again, very tight, concise notation. I can operate over lists, any data structure, using little functions that I can create right on the spot. I don't have to go create a new class in C++ with a new method and figure out where it goes. I just write a little function right there. Okay? Very, very powerful. Currying. Okay, this odd notation we've been looking at here. I'm going to finally explain this. Okay? This arrow means it's a function. So, I got two functions there. So if I take a function of 2 arguments in Haskell, you change it into a function that returns you another function. So I've got a value, and I return a value which is something of type A arrow A. So it's another function. So basically, instead of saying, you know, as you would say in C, I got 4 arguments, and then I get a return value back. In Haskell, it would look like you have this 5 things strung in a row with these arrows in between. Let's see how that's kind of useful. So I've defined a function f here, which takes 2 numbers and adds them together. Right? It's got 2 arguments, x and y, and adds them together. And see the compiler or the interpreter has figured out that I've used the operator plus, and that refers to numbers, and so it's figured that out for me. So now I take f and apply it to 1 argument. And I get back something that is a function that takes 1 number and returns me another number. So I can create functions that by just giving an argument to one function, it'll do a little bit of computation and return me a new thing, which is also a function. So let's see how that's used. I can say g is f of 100. Okay, and then g is a function. I can apply it to 7, and I get back 107. It's a little mind-bending. It's not something you find in any other language, really. But you can see it very nicely in sections, which are exactly this idea of curried lambda functions, but with operators. So I have the operator plus, and I can say plus 100. Well, that gives me back a function of 1 argument that returns another argument. So if I take 100 plus 100 and I give it the number 7, it'll return me 107. Okay, so it's a little tricky, but 100 plus is exactly the same as lambda x is x plus 100. So it's if you want to say you want to double everything in the list, you say map times 2, apply everything in the list. You've done like that. Non-tutorial, but a very cool thing. Another nice little syntactic feature, you can take any function, here's element, which is as if this thing is an element of this list. And if you put it in backticks, you can use it as an infix operator instead of a prefix operator. So you don't have to go defining crazy punctuation to make new operators, you just stick it in there. So you can write mathematics where your mathematics is words that you use, and you can write infix expressions for them.
So if element took 3 arguments, would it take 1 and 2, or does this not work?
Well, if you took 3 arguments, you'd apply 2.
You'd apply 2 and you get back a function.
Yeah. And you need to...
Okay.
Yeah, you need to structure that a little bit differently, but yeah, you could do that. Okay, so here's something that's a little hard to explain, but man, once you get used to it, you never go back on this. All of this stuff has been leading up to these type classes, type inferred, all this being able to curry functions, but this lets us stick them all together. So here's a lame symbol. This is the dot, okay? It should be the little circle that goes in between functions in your math textbooks. But they picked a dot. And this is the type signature is very difficult to read. It's not for me now, but when I started out, it was very difficult to read. But basically, I have a function that starts with one type and gives me another, okay? And now I've got another function that I want to pick up the result of that and give it over here. That's what function composition is. So I've got one function that goes from A to B, one function that goes from B to C, and I want to stick them together so I get something that goes from A to C.
Like a pipe.
Yes, exactly like a pipe. Except, unlike pipes in Unix, which are of one type only, this thing will let you change the types and do correct type checking for you. But there's a great deal of discussion on how to make something that will replace something like Bash, which is enormously effective, but in interactive and all these things, but using these things, and people are beginning to break down that sort of thing. That's one of the things we're very interested in, because I can give you lists of things where Bash is just the right tool to use, but it's a nightmare. Okay, so here I take two functions and I compose them, I put them on zero, and I get back an answer. And this is cosine of 0, sine of cosine of 0. Okay? Here's this is David's favorite one, and it's called consperse. It's a little tough, but, okay, so I've got a string, which is the list, right? Make me a frog. Words takes a string, and it looks for spaces, and it breaks up a string by spaces, and so now I've got a list of words. Intersperse says take a list, and everywhere you've got a comma, add a new element where I can stick this in between. So now I've got a list of words with commas in between them, but the commas are strings in that word. Well, cat takes a list of strings and put them all back together. So here I've taken a space-separated string and I've put it into a comma-separated string using only standard list operations and functions. So, wow. Suddenly you go from looking up the operation that might do this in a big Rome library. I mean, you get the kind of behavior that Perl has with strings, and just anything you want to do with a string, you can figure out how to do it in 3 seconds if you're willing to learn Perl, which I was at one point, but I'm not anymore. So, like I said, Lego, it lets you put these things together using standard operations and off you go. I would be remiss if I didn't tell you about lazy evaluation. We'll pull the first 5 values off of the list. But here's a list of 1 to 1 million. Here's an infinite list. And it just gives you the right answer back. Okay, so how does that work? Well, the compiler does something called by need, or called by name. So when it goes and it says, I've got this list of 1 to 1 million, I guess that's 100,000 there, it doesn't actually go and fill out the whole list. What it does is create a function, which when you ask it for the head of the list, it'll give you the head of the list. And in this instance, this is a predefined construct. It knows, well, I've just got to give you all of it in order, so I'll just make a little function that adds 1 and returns you the value. So there's some overhead associated with laziness. But on the other hand, you can get out of certain things, and you can do some really cool stuff with it. So here's another construct. This is the Fibonacci series. So this is Fibonacci series represented as a list. So we start with 2 values, 0 and 1. Those are the 2 seeds of our Fibonacci function. The colons say concatenate these guys under the front of the list. Okay? Well, all of a sudden we run out of values and we start getting into this thing. So this thing, square bracket, some expression, a vertical bar, and a square bracket, is a list comprehension. And you see these in Python as well. So this is directly taken from your math textbooks. So look at any textbook and you will see curly brace. They define a set as the set of all x such that x is an element of this other set. That's exactly what this is. So you could replace this with curly brace, vertical bar. This is an element, and it's designed to represent that. But it's really a tricky little list operator. But let me just show you that this thing is defined in terms of itself, and it's determined in terms of the tail of itself, which is a list minus its head. You take the head right off and give you the tail and that. Well, so a Fibonacci series, if you imagine 2 infinite lists, right, and you add them together piecewise, if you set those lists up together correctly, then you will get a Fibonacci sequence. And basically, you take the two lists and you shift them down, and that's how you do that. And that's what that tail does on the
So
shift.
plus automatically sort of maps itself over the list.
Yeah. This thing will actually do a Cartesian product for you. That's what this operation is doing. You could say the set of all x comma y, so it says x is in this list, y is in this list, and it'll give you back the Cartesian product as a list. So I just wanted to show you that this is the kind of mind that Haskell comes from. They love to play with these things, but they haven't ignored the real world either. Incidentally, that's not quite stated Haskell yet, but they haven't ignored the real world, and that's the most important part. I/O monads. So the downfall of all functional programming to date has been I/O is not a value. Dang it! So they turned I/O into a value. And this again happened about 5 years after they started the language. And what they did was, instead of saying, I'm going to do some I/O operation now.
I don't think anybody in the room, except for our friend who knows why I/O doesn't make sense in
Oh.
functional language.
All right. That's a very good point. So let me try to explain that. If you take a big expression tree, you've got one big sub-expression over here, one big sub-expression on my right, one big sub-expression on my left, and you got a big plus operator right up here. Okay? Any language, like C, will say, I don't know which one to do first, I'll do this one first. And it evaluates this whole thing and comes up with an answer. Then it evaluates this whole thing and comes up with an answer, and says, okay, now I can add those two together. And it picks which way it's going to go. If you write A plus B, and those are non-trivial expressions, both A and B, it'll pick which side one or the other. If you have side effects going on there, they happen in any order it wants to happen in. Whichever C picked to do A or B first, that's when those side effects will happen first.
Like reading, side effects mean reading things.
Meaning reading or writing or changing the value of a state or something like this. So, the definition of a function in mathematical terms is it should always return me the same answer for the same inputs. If you're doing I/O, that's not true. A function like getLine has no inputs, but it always returns you a different answer because it's coming from the outside world. So what we've actually done is, well, you see there's no arrow in here. So in fact, getLine in Haskell is not a function. It's a value. And it's a very specific type of value which the compiler knows about and the type system knows about. And it's designed to say, hey, what I am is something which in the outside world, when you execute me, I will give you a string back. But it doesn't actually happen now. What you do is you write an expression that says, oh, I need to evaluate these things. And the expression syntax orders what goes on. It's kind of tricky stuff, but in fact, it's the hardest thing to learn about Haskell. But it's actually fairly interesting to put them together. So, oops, I didn't change this. This should be getLine and this should be putString. The whole point here is to take I/O and represent it as something mathematical. You do this all the time in your programming. You use monads all the time in your programming, in effect. So for example, when you open a file, you get back a file handle, right? And you give a file handle to the getCharacter function, and it reads that file handle and gives you a character back. And that, you could, if you weren't careful about how you set things, you could read the character first and then open the file handle, right? And if you do this in C, if you try to put the file open right next to an ampersand, like if I succeed in opening the file and then read the character, C may try and do the wrong thing and generate an error because it will try to it may evaluate the thing on the right first, which depends on the thing on the left, but you didn't say that.
I agree, it won't do it for N because.
Well, yeah,
shortcut.
I'm trying to, but the point is, this thing gives you a string, okay? This thing takes a string and gives you back something which, when executed, will put that string out onto the outside world. And then you put them together like this, and there's no way, there's absolutely no way to get at that string without using this operator. Okay? So somebody just defined monads in terms of spaceships. Okay? So the big bad space out there is the I/O of the world. And if you're in your spaceship and you're an astronaut, you can take off your spacesuit and you're in good shape. But if you want to go from one ship out into space and into another, you've got to put on your spacesuit. You've got to put yourself in a box and send yourself along in a spacesuit. And then you go into that other ship, and then you can take off the spacesuit, and then you can do normal computing. But as long as you're outside in the I/O world, you got to be in this box, which is called an I/O. Okay? So it takes a while to learn how to use. It takes a while to appreciate why you might be doing it. But here's the key thing. The type system is enforcing the sequencing of I/O. You basically have to explicitly say where you're doing I/O, and you can never get around that. And then what the compiler gets is a whole bunch of values that it knows how to deal with. Some of those values are things which will do output to the outside world. Some of the things will do state transformations. So the monads deal with all things that encapsulate state. Either the outside world, because the outside world is a state in itself, and if you get a string, then you have a string and a new outside world, which doesn't have that string on it anymore. So it takes care of all of that. And it's very nice because then the guys behind the scenes with the magic of the compiler can start changing things around. And if you change your definitions a little bit to allow for parallelism, then you can do all the I/O you want, and it can figure out where parallelism needs to be happening. A difficult subject, like I said, not a tutorial. I saw a question back there, but I'm almost done here, so let me go through. So laziness works in the I/O world as well. There's some syntactic sugar for working with I/O monads. So this almost looks like imperative programming, and it's designed to look exactly like that. So you can do I/O in a purely functional way, but it looks like, well, I'm going to read a file and put it into the value of X, bind it to the value of X, and then I'm going to put this string out. Well, I might have obviously wanted to say put string on X, and that's how you would do cat, for example. If I replaced hello world here with X, that would be cat, the Unix command cat. In this case, I neglected to use X, so the laziness took over, and I never actually read this big file. I just put out the hello world. So the laziness, if you use it correctly, can do some optimization for you. Then you can set up all these values to be computed, but if you never demand them, then they'll never happen and they'll just get tossed away. So the I/O monad helps you sort all that stuff out. Okay?
Except for the case of reading the really big file to delay the processing, putting out the string in the word.
Yes, that's true. So practicality, I remember I said that the Haskell people were not just interested in mathematics, they're interested in real world stuff, and there's a lot of real world language support going on. One of them is quick check. You can give it a function. Given a function that you wrote, you can write a little thing that says, here's a property of this function and returns a Boolean. So for example, reverse is supposed to reverse a list. If you reverse a list twice, it should give you back the identity function. This little quick check thing is about 300 lines of code. It will generate random values for that, and if none of them satisfy the property, then it will toss it back out. It's trivial to use, catches a whole bunch of bytes just like that. HU is a sort of more production kind of things. For user-defined tests, you can just make a big test suite of values that you want to go through, and then run it as you build your package. Cabal is a packaging. It's an autoconf replacement. It's sort of standard tool now for, you got your Haskell library, you want to put it out there, Cabal is supposed to help you with that. Top of the charts, Debian has a site where they have like 20 programs that are test suites for efficiency on the language. And Haskell people, they didn't really, the programs are very odd. And at one point recently, they realized they were down around number 10 and they got pissed off. And so they started optimizing those programs and they zipped right up to the top of the chart. So if you pay attention, if you understand the language, you can make it as efficient as anything else, okay? Fast pack strings, I'll show you more about that in a minute. This book, Okasaki's Purely Functional Data Structures, if you're into data structures, this is a must read. It's all about amortization, and it's a really interesting thing. A growing community with Haskell. Like I said, there's like 150 people on there on the IRC channel every day, and the language is continuing to develop in a very careful way. And they limit. The fast pack strings, ooh, I didn't get this, I still didn't get it in. All right. So the fast pack strings was recently done. Remember it said strings are lists? Well, it's a little inefficient when you start getting up to big files. So this guy in Australia, as a student, started writing these things. I'm going to try to have gigabyte files. Unacceptable performance. He started writing the fast pack string library, and he's got a one-line version of WC, which runs just as fast as this version in C, but it's, you know, it's like this many characters. I'm sorry, I don't have it here, I lost it. But it just processes gigabytes of data.
This is kind of like ropes, like cedar, the ropes in cedar.
Yes, yes.
In fact,
yes.
it might be done internally the same.
And in fact, one of the Google Summer of Code projects is to take the fastback strings and implement exactly ropes. So the point is, we have this lovely mathematical definition of strings. It's a little inefficient. Somebody's gone in, all the same operations used on strings work on the fastback strings. So you can use them almost interchangeably, but they're fast. Yeah, okay. The point of this next 3 slides is simple. People have looked at languages like C, and I can't express my problem in a small enough, it's too much overhead working with C to say work with, hence the invention of block to work with these things. So these are 2 examples of recent things that people have put out. Haskell is a markup language, using some very tricky type definition stuff. This guy, Oleg, made a little thing so you can write things that look exactly like HTML, but they're actually Haskell code, and they're type checked. So if you were to reverse like the head and the body, for example, that would be an invalid construction, and the Haskell thing would push it back to you. So you can actually write what looks like HTML. It's code. It's statically type checked, and so it's a little language all in itself, but you don't have to rebuild the whole language yourself. You just write some type systems and off you go. So there's some cool work going on there. This is a grep that's about 20 lines long, using some pattern matching that this guy wrote. You know, the 5 most valuable features of grep, can you implement it? Zap. You turn it into fast pack strings and it's as fast as grep. Actually, I'm not certain about that one. It's close. But the point is, the language is so, they've worked on the expression of code so much that they can get these things down there where you're not tempted to go to another language if you're willing to put enough time. Haskell.org, if I've excited you, is the place to go. There are mailing lists and there's IRC channels. Both, there's one called Haskell Cafe and the IRC channel. They're all very newbie friendly if you just go in there and be polite. It's one of the most civil places on the planet, and you'll get a lot of help as long as they don't think you're, trying to get a homework problem answered. But the guy who did the fastpack strings, I was on the IRC channel one night, and somebody came in and said, "Hey, I'm using the fastpack strings, but you didn't define these 3 functions for me." He said, "Well, I didn't think they were needed." And the guy said, "Well, here's what I was trying to do." I said, "Oh, well, you're right, they're totally needed." He said, "Well, okay, map is done. Okay, this one's done. This one's done." And then he put out a Darts repository for the guy to go and pull code from. 5 months later, he had these 3 very important functions that were additions to the library. So, I don't know, it has the feel to me that we can actually make headway. Working in Linspire for 4 or 5 years, I feel like the same thing is going on all over the planet. people reworking the same little core things, and we still don't have, we're just barely getting good photo editors, barely. And you still find people rebuilding GCC and switching from this language to that and making this new little tool as a different version of Make. And ever since switching to Haskell, I started writing things that work. A full range of functional programming going on inside there. If you want to convert from one format to another in sequence and values and back in terms of your data structure, all that goes on inside the IO monad. The whole point is that if I do IO, I give it to you wrapped in a box. And you can't get that box, you can't get the value inside the box unless you promise to pass a box on to the next guy. Anything else you want to do to that object inside that box and pass it on to another box? Absolutely, you may do. I'm not sure I've completely understood where the misconnection is there, but yeah, no, it's very deterministic and very powerful, and there's no randomization there.
I guess, for instance, if I were reading a file of numbers,
Yeah.
how do I get a number out of this string?
Well, I mean, one way is just, I mean, your parser would return you IO strings. You would make a function which took a string and converted it to a number.
Return.read.
Yeah, there's actually a function. I don't have my interpreter on here. There's a function called read, which is the inverse of show, basically. So show takes an integer and gives you a string back. Read will give you a string and give you back the value. So you would compose. You would compose get string and you put it in something in here. And actually, this is what this thing does. The return function lets you take something and put it back in the box.
Are they then back at runtime checking?
No. Well, I mean, yeah. You can't have to do static type checking on data that's out in the world. But you can insist that the read function guarantees that it takes a string and returns you an integer, and it will complain and throw an error, an exception, if it was not given something that was a valid representation of an integer. And after that point, it guarantees that it will only return integers, and off you go from there.
But to some extent, I think the confusion, I'm guessing, is because your example was about strings, because they're important. I mean, you could do, I assume you could do binary IO in Haskell.
Yes. Yes.
Right.
Yep.
So I think the point is that he was talking about strings because they're kind of common and important, but he could be pulling other things out of that. I mean, not that I actually understand these things, but the problem they're trying to solve has nothing to do with strength. The problem they're trying to solve is that the same value doesn't come back. So even if you're doing binary I/O, it's just different binary strings come back.
You're still getting characters.
So I'm trying to look at this and compare it to C or C++ and see where some of these concepts actually leverage into things just working. And it seems as though you're dealing with the same types of problems. You have to know the implementation, or I mean, you look in.
You cannot get around parsing. There's no magic around parsing. I mean, if you at runtime your program goes out and parses some data and brings it back in, you have to deal with the fact that the data might not be what you expect. There's no.
Well, in the same way that I would package up some object to read, spit out numbers,
right.
So you modularize. Regardless of the language. So
right.
A lot of these things look like forced modularization.
Right.
And forced hierarchy of data types.
Right. Now, I mean, the problem you're talking about basically is marshalling and unmarshalling of data structures automatically. That's not provided by the language, but there are libraries that address that issue. And so they use these mechanisms to try and get the right answers back in those instances. But there was actually a recent discussion on the Haskell list about how much you can control the outside world and how valuable it is. I mean, and one of the founders was saying, well, the lovely things is once you get inside the program, then it's all predictable. But as soon as you deal with the outside world again, well, then you've got to deal with the outside world. And I couldn't figure out why this disturbed me so much, but the answer was that that's really only true insofar as the kernel is providing you, and CPU and memory controller are sort of providing you this nice memory space and that nobody else has access to. But, I mean, if you try and do these things on file systems, you may run one program, you may have created a file out there, and you say, oh, well, I know that file was there, I just created it. You run some other program, and you come back and you get that file and it's gone. The outside world, I mean, that's really true of your memory space as well, it just doesn't happen very often.
You can just ignore that and keep going.
Is this a really serious requirement? Of
No, that's quite right.
Okay.
Sorry.
Just wanted to check.
I mean, I would recommend it personally, but it's not a requirement. Any other questions?
So, since we were talking about efficiency,
Yeah.
has anybody attempted to implement, let's say, a fast Fourier or fast wavelet transform natively in Haskell and looked at them?
I'm not sure about a fast Fourier transform.
Because
There's some
you
linear
can't do
algebra.
FFT, you can't do anything.
Yeah.
Sorry.
The answer is if you're willing to forego a lot of the nice little things you've got, Simon Peyton Jones, one of the founders, says that Haskell is the finest imperative language in the world. Honestly, you can make it spit out very, very efficient C code if you like, if you want to.
Well, okay,
So-
what I'm kind of getting at is that there's a forgotten group of people who write most of the world's research papers for whom C++ is not, I mean, I have a friend I talk regularly to who still doesn't use C++ because he can get 10% faster code in Fortran. So that's the, anyway, I'm just curious
No,
what happens when you do that, or no Camel, which has a reputation for producing very efficient code.
Yeah,
So-
but still, Fortran is a special niche in that they've tackled a lot of the mathematical operations.
Well, it is, but they've screwed it up recently, and there's now, he and I just said, there's now an opportunity for a language which is higher performance than Fortran, thanks to the recent actions of the committee, weirdly enough.
I would say absolutely, I would expect Haskell to win in the end on this subject. One of the reasons is parallelism. And if you're careful enough about structuring the computation and your data, you can go to the parallel versions of GHC and try and get some parallelism.
The reason I ask is I would have guessed the opposite way. I would have guessed that laziness basically is what would kill you.
Well, I mean,
we already know.
the language actually provides for getting rid of the laziness if you really want to. So there's an operator called seek, which will force evaluation now. And it was actually quite controversial to put in, but a lot of people demonstrated instances where, hey, these are sort of dual problems, right? Sometimes you want to read all your data in, sometimes you don't. But if you pay the cost of reading it in lazily, when you know in fact that the entire thing's got to come whipping through.
I assume that what's happening under the hood is you're creating a thunk and
Yes.
and blah, blah, blah. Right, that's what I'm saying is that for that class of program, essentially people will go crazy. Oh my God, I created a thunk and I got a cache miss.
Yeah, but that's
Well, it's very specialized. I'm just curious, though, since you were talking about performance, I'm just curious, what happens when you sort of put it in this weird specialized arena and, you know.
People, I don't know what the competitive numbers are. People have written some linear algebra things. I think basically it hasn't been used for doing any of these big serious number crunching things yet. Which is why, in fact, operating system stuff is actually fairly small stuff, you know, so.
Yeah, it's.
And where you care about being able to read it cleanly and be correct and not let a lot of errors in. And actually, if you, we know from some of our experience that Microsoft, looking in the installer code for a lot of these things, we worked with the wine people for quite a while. Every time the installer goes to put something on your system, it will double and triple check whether the file exists, whether the directory exists. There are all these redundancy checks in there to deal with what we were talking about there, about the outside world will change underneath you. And that's where you want some mechanisms to help you, hey, did I get these correct? There's some more advanced tricks that we've been thinking about for using the types to represent the expected state of the system. And if we go and there's an error, then we say, well, then we gotta unravel this set of assertions we've got and tell you what went wrong. And we run into this all the time when we write big scripts that do a whole bunch of stuff and make a mistake. Go find this file and, oh, it's not there anymore. What, you know, you're 1,500 lines into this big complicated script. How do you figure out what went wrong? Well, being able to represent the training assumptions that you had, and roll that back out and print out some XML that might tell you what's going on would be a really good thing. So, on the number crunching, I don't know yet, but theory says this stuff is going to win out.
Well, okay, so the reason I sort of think of this in this arena at all is because the best non-proprietary FFT implementation is you know what it is.
It's the one
for transform in the West.
Yeah.
Which is written in C by an OCaml program.
Right.
So what I found interesting is that they still had to write it to C, but they're using OCaml to generate it.
Yeah,
which is interesting.
I would think you would probably want to generate a Haskell program, but you'd probably not have to write it to C if you're careful about it.
Yeah, I mean that was kind of what interested me, you know.
There's a few points around there. So floating point performance hasn't really been a serious goal of, you know, the optimization backends and the compilers. You probably don't want to try and write that code. All this laziness stuff, that is something that the optimizer works really hard at figuring out when it's not necessary to do this stuff.
I mean, it would have to essentially.
It's actually getting pretty clever about doing that.
Yeah.
I also ask these questions because I always laugh when the Haskell people talk about mathematics because they also mean a very restricted set of mathematics.
Yeah, they mean abstract algebra for the most part.
Well, they also mean a lot of,
well,
they also mean discrete math. And those of us who spent, you know, most of our lives doing continuous math, it's interesting, and it's just not something. These are people who don't talk to each other.
Yeah, that's right.
They do the kind of math that mathematicians.
Yes.
Actually, that's not
modern
true.
mathematicians.
They do the kind of math that computer scientists that have mathematician envy like.
Well, all right. Anyway,
Euler was a mathematician. Let's not forget.
I mean, there are certainly problems that we do not recommend people tackle with Haskell right at this point. I certainly do not recommend that. You know, I don't expect that everybody's going to take to Haskell, but the story I've been telling recently is, I mean, I was the youngest of 4 brothers, and when I was 6, my oldest brother was 13, my grandmother said, "Dude, look, we got a bridge quartet here," and she taught us all how to play bridge. So I don't remember a time in my life when I didn't know how to play bridge. And as I was growing up, most of my friends had never heard of bridge, much less knew how to play. And a lot of adults were completely blown away by the fact that I knew how to play bridge, but I had no clue that this was anything that I was too young to learn, so I had just learned it. I never became a bridge master, but 2 of my brothers went on to go for it pretty aggressively at various times. But I learned it young enough that a lot of the other games that came around, hearts, spades, whist, euchre, canasta, somebody would say, "Oh, do you know how to play, you know, this game?" And I'd say, "Well, no, but go ahead and teach me," you know. And they'd say, "Well, this is a trick, and you know, this is a term that I'm like, I know what a trick is. That's fine." And most of those games are all subsets of bridge in one way or another, or variants thereof. If you know bridge, the auctioning is in whist, the trumps are in spades, but only one suit, and they're all just subsets of it. And so I had this roadmap to put everything on. Well, as I progressed through all the languages, Haskell came around and I said, here's bridge. And this is the game you can play for a very long time if you're willing to devote the time to it, basically. It's non-trivial to learn, but the IRC channels and the tutorials are all getting better. People are writing tutorials every other day, it seems like. I didn't understand this bit, so I wrote a tutorial for it. And there's a big wiki and you can add to it.
Yeah, I know there's that, which is very good, but eventually they're going to have to actually, going to have to get to the point where they have a small number of ones that they're pointing people to. Because that was one of the problems actually is that when I looked at it, there were too many tutorials.
Yeah, that's
Which means
right.
that you can't, which means that almost certainly the tutorial you need is there, but you'll never find it.
And that's why the IRC channel can be a really good thing. You go and you just pick a particular topic and write a little thing, go out to the IRC channel, get some help on it. You can move things along. The cafe is precisely for this purpose, so you can say, I'm trying to do this, I'm trying to represent my fast food transform, I don't care about speed right now. How do these arrays work? And people will type. This is the purely functional data structures by Chris Okazaki. This is his PhD thesis. This will open your eyes on data structures in a big way, in many ways, and certainly about purely functional ones. And this is Paul Hudek. He's one of the founders of the thing. He teaches you Haskell by using a little graphics library, and you can do some animation. And with a little work, that graphics library still works today. It's distributed with the compilers and stuff. There are a couple of other books out there now too, which are good as well.
So are there good bindings to write KDE or GNOME programs in Haskell?
There are GTK bindings, but GUI stuff is one of the messiest things out there. And there's some really cool research projects done I was actually in research in GUI stuff, and then I was just thinking about this stuff, and then Hudek came out with something called Fran, which basically incorporates time as a first-class variable into a little language to do animation. It's really, really nice, but Microsoft locked up the code, so I think they did. But there's bindings for GTK and for WX, the WX widget set, and then there's this third sort of graphics library. But we have looked at KDE bindings. We may do it when we get time. It's fairly nasty the way Python does it. The libraries that Python generates for their binding to the C++ are larger than KDE itself.
Really?
Yeah.
That's impressive. That's impressive, because I actually compiled KDE.
Yeah, so I mean, it's basically for every method in every level of every class, they generate a little wrapper function, and then they call that. Your memory just goes out the door. Why did my system get so slow? Wow, this stuff is interpreted fast, except for that library it has to load. So the bindings could be done better. That's not Python. So, other questions? Didn't understand anything? Did understand something? Thought it was cool? Didn't care a whit? Really wanted to see a demo of CNR? FreeSpire is going to be released this summer. GHCI is the interpreter, yeah. Okay. There you go. So I can demonstrate a little bit of this.
That's my version of click and run. Set up the network first.
The very first thing you do in GHCI is say :help, and it tells you all of the commands which you use to operate things, which there's no equivalent of that in the OCaml interpreter, which is why I was always frustrated with it. But then you can, the most important thing is you can just dynamically load modules by saying :module plus data.string, say. It is not a module and you don't have it installed. All right.
There's no such module.
There's no such module ever. There we go. So that adds it in. You can put a minus in there to remove it back out. You can mix and match and get all the modules in there, and we'll show you what your prompt is. And then you can do things, so you can start playing around and you can say, okay, what's the type of, say, the plus operator? Well, it's type AAA with a numeric thing on it. Just go off and play right there. I sort of glossed over this, but another thing that we really like about this is Haskell is very, very, I mean, this :n thing, it's the syntax you use inside the interpreter, but other than that, you use just exactly the module syntax that you use in the code itself. If you write a little bit of code, you can say :load that little bit of code and pulls it in and off you go. There's very little difference between the interpreted world and the compiled world. It's a very seamless transition. OCaml, that's not the case. You have to stand on your head and kind of make things go. And it's much more like Scheme or something where they really got that seamless transition very nice.
How do they deal with binding with external languages?
The GHC, the Glasgow Haskell compiler, has both a library for generating things, for generating bindings for more complicated things called Haggis, or they're all Scottish names for them. Green card was the thing, and there was another one that was done. But these days you can just say, oh, here's a foreign function for C, and off you go. And there are lots of examples of how to do it. That was another thing. They paid attention. I was at a meeting where in, I don't know, the mid-90s about there, where they were saying, look, we keep writing all these cool languages and nobody uses them. And so Phil Wadler took a poll saying, why aren't you guys using it? And I said, well, I got about 1 million lines of code over here, and you want me to rewrite it in a language which, you know, I'd love to play with that language, but what I want to do is work on my problems because I got 1 million lines of code. So that was another reason. Haskell was a point where everybody working on these languages and theories could, not everybody, but a lot of people could come together, and what they do is, hey, I've got this proposal for a new type system over here, and they implement it as an extension to GHC, and they put it out there for people to use. And then people use it and comment on it for a long time, and then the committee comes back and says, well, this one we think is really nailed right now, and so we're going to add it into the standard. So there's this funneling process that works quite well. Record structures that we have in C, there's no good equivalent of that in Haskell. There are several implementations of them. You have tuples, but you don't have named structures where you can say, you know, the first element is a string and it's got a name of X, and the second element is a string and it's got a name of Y, or, you know, an integer. But you don't suffer for it because you have all these other things, until perhaps you get to the big real world of coding, you know, maybe you've got to deal with X structures or something like that. But there's no way to sort of wedge it into the type system nicely, so they haven't done it yet. They're working on it. Lots of people have proposed things, but nobody's come up with a proposal that everybody agrees is correct yet. They all agree that they really need this stuff in there, but it's not quite there yet. But I have almost never attempted to use a record structure these days.
There actually is something in that will generate access or functions on a tuple with names and look like a record.
Right. But they're still arguing over that. It's non-standard. That's a Glasgow Haskell extension. There are several others that are still under proposal. So you can't rely. I mean, if you're trying to write code that's going to live forever, that's the wrong thing to do at this point. But they're going to come up with something, so it'll be pretty close. But that's kind of the way it works. I mean, it's also the licensing on it. They're very, very strict about making sure that everything, absolutely everything, is BSD style licensing on it. Down to the point of they had a discussion about the wiki and the license you have to agree to when you contribute stuff to the wiki. So you can't put copyrighted code or text into the wiki for Haskell. So in terms of open source, they're really quite good.
Do they have something equivalent to CPAN for the modules?
Yes. There's a hierarchical module system. I don't know all the features of CPAN, but the libraries, the current set of standard libraries plus the extended ones is getting to the point where a lot of people will go out and read the CPAN libraries and say, oh look, the CPAN ones has this Gregorian calendar and these better data structures over here, and they start re-implementing them. Somebody actually made something that would call out to CPAN libraries, but nobody really picked up on that. They couldn't stand getting Perl all over the Haskell code. So, but the libraries are getting more and more extensive all the time.
If you're talking like
hierarchically structured. Sorry, go ahead.
If you're talking like going out and downloading stuff, there's nothing that does that yet. But
well, actually, that's
people are working on that.
On my final page of the talk.
Sometimes you can find this stuff and easily.
Well, one of the things we're trying to do is all these libraries that get out. For us, getting them in a Debian package means we can just go whack and install them all. We're trying to set up cron jobs so when the latest versions are released, we use Cabal, generate a Debian package, and make it go in there. And so you can just use the Debian system to get your new version of it, and off you go. So we're trying to make that happen so that those things are always available. It'll be several months yet, I think.
So as a almost total change, so how many Debian packages do you guys end up having to be the maintainers
Well, nothing that Debian maintains, because they obviously do it themselves.
Obviously.
We've created, I don't know, we've created several hundred of our own, I'm sure.
And you guys
Greatly
have-
varying complexity. Some of them are little configuration operations which go here and there. Some of them are our own version of Firebird and Thunderbird, which are packaged up with customizations. CNR has about 10 for itself.
Well, let me put it this way, is anybody convinced by a DD so that you maintain it in Debian so you don't have to just maintain it?
No, although one person is about to become so. But that's part of the goal with FreeSpire. It takes a lot of effort to get something back to Debian in a form that they'll be willing to accept. I mean, a lot of our earlier stuff was just rip this stuff out and, put some Linspire branding on it and off we go. Over time, we've gotten less frantic because Michael was in a very big hurry to get stuff out in the beginning. We've gotten more organized, and a lot of this Haskell stuff, there is now a guy named John Gorson, whose name you've probably seen on Slashdot for arguing about the Java license. He's the president of or part of the corporation that sort of represents legal entities. That is a legal entity. When Debian needs a legal entity, this corporation is supposed to handle it. And he's arguing with the Debian project leader about the whole site.
Is this the thing where I think it was just today I noticed the Debian project leader said, do you not? We could just walk away from that.
Yeah, that's the argument going on. Well, John, in his other world, has migrated from Python to OCaml to Haskell, and has now rewritten a lot of his Debian tools in Haskell, and we're planning to take a lot of our auto builder and stuff and funnel them back to Debian through him, which gives us an advocate on that side who is both Debian and Haskell, and he's kind of excited about that. Plus, there's several other Debian developers are big Haskell fans, and we're on a mailing list with them about getting the packaging up to date, current, keeping it current. We're trying to work with them to get that stuff done. So we've been a little insular often because we felt we couldn't, make the promises to Debian that anybody as a Debian developer would want them to make. With FreeSpire, we think we can do that. So we're moving more for that direction.
I was wondering if you could talk a little bit about how you deal with the ongoing challenge of merging your changes back into each new release.
Yeah, some time ago, we about 2 years ago, maybe 2.5 years ago, we got fed up with CVS, and Debian has mechanisms all in place for Debian to use. But if you're they've got upstream and then Debian's downstream, and they catch all the software and they apply all these patches and reapply them. And we're sitting downstream of Debian, so there's a double layer, and their mechanisms don't recurse. So, we looked around at source code control systems, and we settled on Arc TLA, which is, like Haskell, has a fairly steep learning curve.
Not Darks, huh?
Darks was really, really raw at the time. Darks still does not have a lot of the things that a real-world commercial developer will need. For example, if you put in a Debian package and you check it out, the rules file, which is the make file for the package, will not run because the executable bit has been turned off on it. It doesn't preserve that. So there are a lot of things where TLA treated the metadata on the file to be the same as the data in the file. If you change that, it records that and puts it in there. Darks doesn't do that. Darks doesn't keep full histories. Darks doesn't have quite a lot of other things. It seems to be a very hard problem that nobody really paid any attention to for a long time. The people have partitioned it off in about thirds. Git does some really amazing stuff, and it's getting better, and it's encroaching on these things. But there are a lot of things it doesn't ignore, and it doesn't. Linus created it to do what he wanted to do in a hurry, and that's other people sort of, moving it along. Darks is great if you're doing a developer on upstream code. Man, it's fabulous. It's got like 8 commands. Everything's symmetrics, everything's pure. It was written by a physicist.
Yes, I know. It's the only place I've seen quantum operators. You should use quantum operators for everything.
And TLA sort of takes the patch management to a really high level. And TLA is in so many ways purely functional in that you submit a patch to the server and you're not allowed to really modify what's on the server. It's like Chris Okazaki is purely functional data structures. It's quite powerful. It takes, the UI is not the real strong point there. The command line, there are like 100 commands, which take quite a long time to learn. And it's buggy. And Tom Lord got into a flame war with Canonical over taking they sort of hijacked it from him and got really bitter about them. And then he got sick, and then so. But at the time, as one of our colleagues said, it sucked the least in terms of source code control systems. We think it's still an unsolved problem. We're limping along with TLA. One of the things we're using Haskell for, so we can rewrite some of these tools, so that maybe we can say, just get me all these packages. Look, I got this bug to work on. Get me all these packages, because the bug spans 15 packages. Hack, 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 hack. Push this thing up. Please figure out where that patch should go, someplace up on the server, and give it to the release manager who will figure out what to do it. So we're trying to make things simple for the outside world to just say, look, I see there's a bug here, and I don't even know how to fix the bug. But what I want to do is submit to you a diff in the output of your program, and here's what your hardware detector generated, and here's the frickin' option that needs to go in the third paragraph of my xor.conf, and here's the diff. Please make your detector do this on my machine. We have all the components in place to do that, pretty much. We can take a snapshot of your machine and have you send it back up to them, and David often sorts that stuff out. But we're still configuring X servers after I went to the second X conference in 1986. That's just way too frickin' long to not have solved the problem of how to bring up a Windows system on a video card, in my opinion. It's just, it's terrible. That's what I mean, this core set of stuff. It's just all broken, and it's broken because we're all the people who use it. We don't know how to fix it. It's like, oh, well, that fell off the top there. Yeah, never mind, I'll just put it right back there. You didn't see that. I mean,
X is a special case.
No, it's really not. It's really completely not a special case. Software is very hard. Getting software to the point where it works mostly, where you can tell somebody just how to get it right in there, is pretty easy. Getting it to always do the correct thing down the line in a heterogeneous, complex world is not easy, and it takes an awful lot more effort.
X wasn't developed for like 10, 15 years. That's kind of special. X was in deep maintenance mode for...
Yeah, but
that should have made it easier in theory.
Yeah.
Well, no, because it was in deep maintenance mode in a deeply broken state.
But look, there's all kinds of active things like USB drivers, software suspend and resume, all these things, they all break repeatedly.
Sure.
Of course, they have terrible things to deal with. They have BIOSes to deal with that come from random manufacturers and have all kinds of bugs in them. The standard way, if your laptop doesn't come up with the right resolution to fix that, is to get somebody to hack the video BIOS and put the frickin' right modes that are supposed to be in there for your LCD panel, and then you write that video BIOS back in every time you boot. And that's just totally lame, because the manufacturer was not following the specs that Intel gave them. Intel has now instituted a program, actually, where they're trying to follow their equipment all the way out to the end of the line to make sure that you can get a piece of hardware and software together that's working together. They're working now closely with the ALSA people, the kernel people, and the X people.
So a reference driver will actually work?
Yeah. And provide the reference drivers before the product is released, not after.
I mean, this is why everybody else in the world, from Apple on, has always wanted to be vertically integrated.
Yeah, exactly. But I think I dream. Let me say that I dream with these techniques we can start putting a next level of reliability into those things, and make it so that you don't have such carelessness going on in your code. I mean, the fact that you have to install a Linux system and then configure it, it's totally lame. And we try it, I mean, when we're doing our jobs, the Linspire installs and it just comes up, and I set the caps lock key to be a control key, and then I'm ready to go. All right, install a few other things, man pages and compilers. But I don't have to find USB drivers, I don't have to find the, if we're not finding those things, it's a bug, basically. There was some other thing I was going to say. Oh, right, did you all see there was a new announcement for a new grep? Lots of new features in grep. They sort of integrated it with Find, and all these new features. Man, I'm gonna, if I get a weekend where I got nothing to do, I'm gonna sit down and rewrite that whole frickin' thing in Haskell. And I think David's written 3/4 of it already for the detector for traversing trees and all this other kind of stuff. I bet we can re-implement that thing in much less code, with much more clarity, in a very short amount of time. I think it would be a really interesting challenge. But a lot of the GNU stuff, I think, is, I've grown up revering it, but the more I actually have to work with this stuff, the less I like it. And Bash, a wonderful thing. I've done amazing things with Bash, but I'm finding more power here. It's still young, it's still raw, but I'm finding more power here. And it's 9:15, 2 hours after I started, and I'll go on as long as you like. But you don't seem hungry and you don't seem impatient, so but let me know when I should shut up. So go ahead.
With the infrastructure that you set up, you have some, this very complicated system, and you need to be able to look at the state of a whole subset, some subset of this. You have some mechanism for describing what parts of this system.
Well, actually, the web director was bugging me today about whether I'd written up the release notes on the meeting for which we were doing that. So, since somebody asked about source code control, TLA has this, like I said, this sort of functional tree model of source code in which you can basically, you apply patches to a linear branch, and you can, a linear line, and you can branch off, but at some point you can say, just tag this thing back over here, and this thing, exactly what was over there, that's now the head over here. So you don't have to worry about merging in that operation. It's a direct replacement. It's, this thing is now exactly this. Well, Debian has this structure of a big tree of packages, all of these interlinked dependencies. There are two sets of dependencies. There's the build time dependencies, all the packages you need to build and compile your program, or whatever package it is, whether it's a program or not. And then there are the runtime dependencies. So you have these two interlinking sets of things, which are cyclical. David's been fighting this for a week now, trying to rebuild these things. If you actually run around these build dependencies, they're cyclical, and you will rebuild your packages forever unless you fix that. And it's not exactly, unless you break the cycles explicitly, it's not exactly clear which order it should be built in. But Debian does this by hand. A maintainer is responsible for noticing that his build dependencies have changed, have been uploaded to the repository, and he's supposed to fix any bugs and re-upload it himself. And they have an auto builder as well, and they've got some of the stuff, but they don't publish these tools, they don't clean them up for the outside world so much. And so David's been working on a version of Haskell, and Jeremy Shaw has been working on a dependency engine to try and sort some of these things out. So now you have the problem, we always had this problem. For example, David, the terrible thing about working on the detector is if you get anything wrong, everybody stops. Because, it's like he puts a bug into the code. This is why we like static type checking, right? Put a runtime error into the code. Somebody goes through the whole process of installing a new OS on their system and comes up and it throws an error when it's reading from the USB drive or whatever. And your whole system just, and everybody curses David because, the thing is always breaking the system. Well, nothing works unless the detector comes through. So it's like your kernel. If your kernel is screwed up, then nothing's going to work. And so it's a real hot point. So getting it correct is where we leverage a lot of this stuff. So that means, but we don't have full control over everything, right? You're pulling in new drivers from NVIDIA, new drivers from ATI, which are binary, new modem drivers, or new kernel patches. Some guy will swear up and down that this is the greatest kernel patch in the world. You put it on 5 systems and it'll just break horribly, right? So being able to go back to the state of where things were yesterday, but pulling the changes that these 5 guys made, but not this detector set of changes, is a fairly challenging problem. But I realized one day, using TLA, that is exactly the problem that TLA solves. you have this little extra problem of having to rebuild all these packages and make sure that their dependencies are right. But in essence, you say, okay, there's the state of the world as it is now. I want to grab that, build my packages over here for a while until I get them right, test them. Then I want to go back and say, did anybody change the world? If not, then I'm going to take this thing and tag it. So exactly the distribution I was testing over here is exactly what goes back over here. If the world did change, then I need to import those changes and decide whether I need to rebuild any of my packages and then retag it back. So we're building a system, and I'm trying to define the semantics of that merging and when it's safe to not rebuild packages. We're all working on that together, so that we can efficiently keep this tree of everybody works independently. You can work on your stuff, you can get updates from the server whenever you want to, and then when you're ready, you can send back your changes. But QA will be testing exactly what you have been working with, which is not the case in our current system, and is not the case with web database.
So it sounds like it's actually system-wide version control instead of just an application-specific version.
Yeah, it's the meta version problem.
And then what do you do when you have some package that hasn't been ported to the new libraries that came out or something like that, and now you have mismatches? And
Yeah, that's the problem you face in the world of Linux, where everybody's on a different release schedule. You either bite the bullet and update the package yourself, or toss it out of the disk, or wait for the next thing to come around. Yeah, and there would be some features I'd love to put into CNR to say, and there are some things we could do that we're looking at. For example, you can install some things into change routes and run them out of change routes. So as long as the protocol of the windowing system hasn't changed, you can do that. That usually X is fine, KDE is not, because the KDE libraries will have been updated and two things may or may not run. Something out of KDE 3 will definitely not run with KDE 4, for example. So, there's also UnionFS, which allows you to overlay these file systems. One of the things we're looking at is to make CNR, I mean, you get errors in your packaging, and if you get an error in your Debian package and installs and it breaks halfway through, it takes a whole lot of effort to unroll that thing. And with UnionFS, unrolling it is really quite simple. The answer to that bigger question of keeping all the versions in sync with all the libraries, sometimes you just have to wait and pick a release point that works. And Ubuntu synchronizes their releases with the GNOME desktop releases, and that's so they keep the bulk of the apps in synchronization that way, and then they sort of shore up everything around underneath it. They've sort of snapshotted most of the rest of the stuff in the previous 6 months, and then they make it all work together with that release, and then they go on. That's more or less what we do.
I'm kind of naive about all the politics within the Linux community, but how do they affect you?
They have, well, I think they've largely resulted in turning my management around to produce FreeSpire. And which is, I think, a very good thing for the Linspire company. Because I think when we released FreeSpire, I mean, I installed Ubuntu, and it's pretty much a standard Linux desktop. If you go and you click on an MP3, nothing happens. If you go and click on an OGG even, not the right things don't happen. So if you're worried about licensing, they do absolutely the right thing, except for when they don't. So for example, there are some binary video drivers that they will compile at boot time in a RAM disk so that you can run those video drivers but not violate the GPL.
Wow. Because you compiled it.
Right, okay, because so that's effectively a loophole in the GPL, and Mark Shuttleworth said at the Debian conference when he was challenged on this that it's been legally tested internationally and it survived. But the rest of us went, but I mean, that's a loophole. That's not, I mean, you're still using a binary driver and you're saying you're sticking by the GPL. So, I mean, we make no bones about it. Look, if there is no open source driver, we'll use a binary one. We don't like to, because they're a real pain in the ass. Regardless of all the politics, the binary drivers are a pain in the ass because you can't fix them, you can't do anything with them. You got to guess what's going on inside of them. I mean, apart from all correctness, they're just really obnoxious to deal with. Although, you know, some vendors have produced some really, really good ones. SmartLink was one company doing moto drivers. They were licensing stuff from the evil empire of the telephone world. That's all they would tell us, but I have to assume it was AT&T or one of the companies that forked off to be, you know, one of the children of AT&T. But they had to pay licensing back, and they couldn't release these things because they were patents, but they open sourced as much as they could, and they supported Linux very well, and then they got bought out by Connection because they were doing too well. And then basically got shut down. So, I'm sorry, I forgot where I was going with that whole thing. But the answer is, the FreeSpire was all about including this community, which Michael Robertson hoped he would just, I mean, I think he correctly assumed that Linspire is not what most of us want, although in fact, I love it because it installs in 10 minutes, it comes up and runs, it detects all your hardware, and you can then go and apt-get, well, okay, I can apt-get because I can get through our firewall. The rest of the world had to buy a subscription through CNR. So now, with free open app tools, I think we're going to a more honest model, which is, look, all the stuff that Linux built, you can have back for free. Anything you want to do with it, you can use it just as you would any other Linux distribution. If you want the services that are not provided by the Linux community, then you come and buy a $20 CNR subscription, or you buy a $60 version of WinForLin through our subscription, and that's where you get to the thing. It's also possible we can retarget CNR to work on other distributions, such as Ubuntu. And Mark Shuttleworth would love that. He would love to have CNR going into Ubuntu, so we may do that deal eventually. The real nice thing about CNR is that you can, this story over and over again, I gave it to my spouse who really wanted Windows, but after a while they were up and running, and they can click and run everything they need to, and click and run as a family license, so your entire family and all your computer sets are covered by one subscription. And we've reduced that to $20 per year. I mean, you spend more on dinner, right? But people still complain about it, of course. But I mean, you hear wonderful stories every once in a while. The woman who went into Fry's, she would buy a laptop every year for $2K. It would get full of viruses. Her IT department wouldn't help her. She couldn't get anybody to fix it. So she basically throw it away and buy a new 2K laptop every year. She goes into Fry's, and we have a machine in Fry's that's $200 with Linspire on it, and Fry's keeps it there as a whipping boy, basically. Right? And they say, yeah, you don't want this because it's not as good as this $2,000 thing over there. Well, this woman was completely pissed that she'd heard this story 3 years in a row. And the $200 machine was on sale for $99. She bought 3 of them. Well, $99 are going to be full of viruses so fast that I'm going to have to throw them away faster, right? So she bought 3 of them. And then she sends this letter to Michael Robertson. She said, why doesn't anybody else know about this? It's like, this thing comes up, it runs, I can do everything I do on my Windows machine. It's not full of viruses. This little $99 machine is running way better than these freaking $2,000 laptops I had. Why doesn't anybody else know about this? Well, because Linux people don't talk to the rest of the world. We're bad-mouthed in the Linux world because we run as root and all these other things, blah, blah, blah. Commercial, you gotta pay for click and run. All that's being fixed in FreeSpire so that hopefully we'll get more people use FreeSpire, or at least Linux people to try it out and have other people run it, hopefully. And then hopefully you can get to the bigger, that will start some buzz and get to the thing. The OEMs love us because nobody else in the Linux world will do the things that business people want. And I mean, everybody's getting USB keys to be handled these days, but I mean, we're the only people with Windows Media Codecs in there, largely as a result of our settlement with Microsoft, where they said, take these, run these. And of course, that's a little hook on their part, right? That gets us to run proprietary formats. But it lets the rest of the world look at 90% of the videos out of the world. So there's this delicate dance in doing a hybrid OS. You want to get more people in. You want to educate them. You want to get them onto open source formats. You want more money flowing into the thing. You want the money flowing into people who insist on open source formats going forward. Maybe we can get rid of the legacy closed formats and go forward. That's what we're giving a shot at.
I'm gonna say, can we call that time here? And if we want to continue discussing,
I got a 2-hour drive back to La Jolla, so
I thought you said you were going to stay up.
I was, but he did. He wasn't going to stay, so. Yeah,
Does that mean we're not going to lure you to BC after all?
I think so, yeah. I would really love to, although frankly, I think in 2.25 hours, you've pretty much sucked all the information out. Well, actually, no, David can attest to the fact that I can pretty much go on forever.
Go to swear? Someplace good to eat?
Yes, very
You hungry? Yeah, BC.
Yeah, I'm totally up for eating, as long as we don't stay
We
till,
adjourned to BC after our Caltech welcome sort of runs out.
which is probably about an hour and a half.
Just like before everybody goes, just wanted to ask if there's anybody else that's, like used Haskell, OCaml, anything like
Yeah,
that.
you're the only one who
Define used.
Doesn't have plans for the summer.
Define used.
We're looking for an intern at Yahoo.
to do Haskell?
Yeah. Haskell, Erlang, OCaml.
Well, yeah, I need to give you guys a card because you never introduced me.
Purpose that you actually showed up today, Chris?
I want you to-